All right, let's talk about something that sounds almost too simple. The perfect hole. I know. But in the world of next-gen manufacturing, what seems basic is often one of the most complex, high-stakes challenges out there. The science behind this, it's incredible.
So how hard can it be, right? You grab a drill, you push a button, bam, you've got a hole. It's probably one of the first things you ever did in a woodshop class. But what if I told you that in the big leagues of manufacturing, that simple little action, well, it's one of the absolute biggest technological headaches they have to solve?
Yeah, you heard me right. In advanced manufacturing, the answer might surprise you. Because we're not talking about hanging a picture frame. We're talking about aerospace parts, medical implants, things that absolutely cannot fail. For those, good enough doesn't exist. The level of precision is just mind-blowing. And if you get it wrong, it's not just a mistake, it can be catastrophic.
Okay, so let's dive into the precision challenge. This is the heart of the problem. You see, you're not just making a hole. You are literally fighting physics at a microscopic scale. You're trying to create this perfect cylinder, perfectly placed, perfectly sized, perfectly straight, in some of the hardest materials known to man.
And the main villain in this whole story? It's a little something called CNC drill walking. So what is that? Well, imagine the drill bit is supposed to go straight down, right? But instead it kind of wanders off course, just a tiny bit, right as it starts to cut. That tiny little wobble, that deviation, it's enough to completely scrap a part that might be worth thousands or even hundreds of thousands of dollars.
And this quote right here, it says it all. There is often zero margin for error. Zero. It's not about getting close, it's about being perfect every single time. We're talking about a single micron, that's smaller than a human hair, being the difference between a part that goes on a jet engine and a piece of scrap metal. So how in the world do they pull that off? How do they get that level of control? Well, it all starts by decoding the tool's own language. We're talking about drill geometry, the actual shape, the angles, the fundamental design of the drill bit itself. That is your first and most important line of defense against things going wrong. Take a look at this. The point angle. Seems like a tiny detail, right? But it's a huge deal. You've got your standard 118-degree angle, which is perfect for softer stuff like aluminum. It distributes the force really nicely. But if you try that on, say, stainless steel, no way. For those harder materials, you need to switch to a 135-degree point. It's a sharper angle, so it bites into the material more aggressively and, get this, that aggressive bite is actually what stops the drill from walking around. Pretty cool, huh? All right, next up is web thickness. The easiest way to think about this is like it's the drill's spine. It's the core that runs right down the middle. Now, common sense says the thicker spine is stronger, right? And it is. A thicker web means a much more stable tool, one that's way less likely to snap. But here's the trade-off. Make it too thick, and you need a ridiculous amount of force just to push it into the metal. So it's this constant balancing act between raw strength and cutting efficiency. So, you've got the perfect tool geometry. You're done, right? Not even close. That's just half the battle. Now we get into the other critical performance factors that machinists are juggling literally every second of the operation. And here's something that might mess with your intuition a bit. When it comes to drill length, longer isn't always better. You'd think, hey, I'll just buy one really long drill and it'll work for everything. It sounds efficient, but in the world of high precision, that's probably the worst thing you could do. So why is that? Because of this one simple rule. Rigidity is stability. Think about it. A shorter tool is way stiffer. It's not going to flex, it's not going to vibrate. And a tool that doesn't vibrate drills a perfectly straight, incredibly accurate hole. So the real pro move is to use the shortest drill possible for the job. You match the length to the depth you need and you get maximum stability. That's how you get a perfect hole. And it's not just one thing. It's everything, all at once. You've got to consider the part material. Is it soft aluminum or tough steel? You have to dial in the perfect speeds and feeds, how fast the tool spins, and how fast it moves. And you even have to think about setup rigidity, making sure the part is clamped down so tight it can't vibrate at all. Every single one of these things has to be perfect.
Okay, so with all this insane complexity, how does anyone actually get it right consistently? Well, this is where we get into the next-gen toolkit. This is where technology doesn't just help, it completely changes the game.
Let's talk about coolant. The old school way was just, spraying some fluid on the outside of the tool. It kind of worked. But now,
Look at the coolant-through technology. We're talking about pumping coolant at super high pressure through the drill itself, right at the tip. It's a total game changer. It cools and lubricates from the inside out, and it acts like a pressure washer, blasting all the metal chips out of the holes so they can't cause problems. The result is just, wow, way faster cycles, and the tools last so much longer.
And of course, the brain behind the whole operation is software. It all starts in the digital world. You design the part perfectly in CAD/CAM software. Then, that software generates the perfect toolpath, the exact instructions for the machine. And finally, that code is sent to a CNC machine that executes those instructions with flawless robotic precision, from digital perfection to physical reality.
So when you combine all of this, that deep, almost artistic knowledge of the tools with the raw power of modern tech, that's when you achieve what everyone in this business is after, mastery at the spindle.
And this quote just nails it. Drilling is often the most precise aspect of machining. Think about that. Out of everything a machine does, making that simple hole is often the most difficult, most demanding task. Success isn't luck. It's the direct result of mastering every single detail we've been talking about.
And really, that's the bottom line here. Deep knowledge plus modern tech equals a true competitive edge. It's that beautiful combination of human expertise, knowing why that 135-degree angle is the right choice, and then having the technology to execute that decision perfectly, not once, but thousands and thousands of times. That's what defines next-gen manufacturing. So I'll leave you with this question to think about. What everyday objects are sitting around you right now that depend on this hidden world of precision? Your car, your phone, your laptop, they're all held together by this stuff. So the next time you see a simple screw, maybe you'll think about the incredible journey of science and technology it took just to create the perfect tiny hole it sits in.